Welcome to Try a Maths Problem Today. I recommend you pause the video and try it yourself before continuing on and watching my solution.
We are asked to express this expression in partial fractions. That means expand it out into multiple different fractions. There's three possible answers for this. I'll write them all at the end and I'll only really go through one of them. But at the end I'll show you how they're all really combined. The way I'm going to do it is I'm going to write out both the bottom rows, x minus 1 and 2x plus 1. And I'm going to say that there must be something above here. I'm going to think about what could be up there. It would be nice if it was just a and b. That'd be ideal. A lot of partial fractions are like that. The problem if it was just a and b, two constants, the problem with that would be if we add these back together, no x squared would appear. So if you think of cross multiplying, this times this, this times this, where would the x squared appear for? So we have to think about that. So that means there must be an x up here somewhere. I'll just go ahead and write ax plus b and a c over here. We only need one of the x's. You could put cx plus d, but you'd just find one of them was actually equal to 0. So there's only one of the x's would stay. Actually, I guess it'd be hard to solve, but you could assume one is 0 at one point. Something like that. I'm not fully sure. But this is one way we could do it. Another way, I won't finish it, but I guess, I'll just show you the steps. Instead of this way, we could have got d plus an e over something plus an f. That'd be another way. Again, I'll show you this answer at the end. But I'll continue on this method. So if we cross multiply this, as I was saying, we then just equate all the x squares, all the x's, all the numbers. So think about cross multiplying here. The bottom row, let me do it down here. The bottom row will just get back to where we were. 2x plus 1. You wouldn't have to write that in. The top row, let's expand it all out. 2x times ax. That'd be 2ax squared. 2x times b is 2bx plus ax. 1 times b plus b plus c times x. And then minus 1 times c. So minus c. Now, what we know is this is still equal to up here. That means all the x squares have to equal all these x squares. And there's only one term for x squares. That's handy. That means 2ax squared must equal 6x squared. All the x's cancel. I won't bother writing the x's in future. That means 2a equals 6, a equals 3. But we've solved one of our numbers. There was a very quick way we could see that a was going to be 3, by the way. You'll see it better when I write all the answers. But it's basically 2x by x is 2x squared on the bottom. 6x squared divided by 2x squared leaves a 3. So again, you'll see that a little clearer when I show you a few tricks at the end. Okay, let's equate all the x's now. Here's an x, here's an x, and here's an x. Except remember a is 3 now. So we get 2bx plus 3x plus cx is equal all the x's over here. That's minus 2x. Sorry, I said I wasn't going to write the x's, but we'll cancel all these x's across. And while we're at it, we'll bring this 3x over, get minus 5x. So we get 2b plus c is equal minus 5. Can't do anything more there. There's infinite answers. If you give me a b, I'll just tell you what c is. But we can stay going. We can combine all the things with x to the power 0 or no x. That's this b and this c. That tells us that b plus c is equal all the numbers over here, and that's 2. That's a simultaneous equation. Quite an easy one to solve, in fact. At least it would be if I remember to put this minus in, which is here. So now it's quite an easy one to solve. We just add these together. 2b plus b is 3b. C plus minus c is nothing. And minus 5 plus 3 is minus 3. We divide both sides by 3. B is minus 1. Finally, we need c. Pick any equation you want. I'll go ahead with this line here. I'll say c is equal minus 5 minus 2b, but b is minus 1. So that's minus 5 plus 2 is minus 3. So the final answer, my final answer here, yeah, let me write it up here. My final answer would be 3, a was 3, so 3x, plus, plus minus 1 is minus 1. That's over x minus 1. And then the c would be a minus 3. Let's leave a plus here and minus 3 up here. And over 2x plus 1. That'd be my answer. It's a perfectly okay answer. Another answer would be this one here. Let me clean this up and let me just write down what that would have been. It would have been 3 plus 2 over x minus 1 plus minus 3 over 2x plus 1. And a third answer, so this one, I'll talk more about this one in a moment. This answer, as we got, the next answer, let me write it in here, 2 over x minus 1 plus 6x over 2x plus 1, or 6x, maybe plus 0 if you want. So this one would have come about if I had wrote a letter here, a number, just a constant here, and then the x on this side. So let's say a, bx plus c. I would have got this answer here. And that I would have got this answer. This one is the one I jotted down in between. Now, how do they all sort of combine? They're all the same. If we think of this one up here, just this term here. First of all, minus 3 has the minus 3 here. These two are the same. So I'm saying this term is the same as these two. And equally down here, this is the same as this. I'm saying this term is equal to these two. So let's see why I'm saying that from this term. I'm going to try divide this in. X minus 1 divides into 3x minus 1. X goes into 3x 3 times. And then what's the remainder? So we multiply 3 by this again, and we get 3x minus 3. Take these away from each other, and we get 0, we get plus 2. That tells me that this divided by this is equal to, so let's put a circle on this, and it equals to this. It equals to 3, that's where that 3 came from, with a remainder 2. So 2 divided by that. Again, if I were to divide this one in here, 2x goes into this 3 times with a remainder minus 3. So if I divided that in, it goes 3 times, and we'd end up 3 times the 1, take that 3 away from 0, we'd end up with minus 3. So these are all actually combined. I would probably say this is the master answer, as it were. Whereas these two are perfectly okay. They will nearly always help you out solving a question where you need to have partial fractions. Okay, I hope that was clear. If you have any questions, let me know in the comments below. Thank you for watching and have a great day.